Hi, my name's Liam, and today I'm going to be presenting to you my report, which aims to answer the question, does distance from Melbourne affect temperature? We're aiming to determine whether there is a relationship between the distance from Melbourne and temperature. To do this, we sourced data from 5 different locations around Victoria in an attempt to find any patterns, trends, or abnormalities. We'll discuss some other topics such as how climate affects temperature and are coastal regions cooler. The towns and cities we chose are Bendigo, Ballarat, Shepparton, Maryborough, and Echuca. As you can see, these are all nearly straight north of Melbourne, so they make a big corridor from the bottom of Victoria, where Melbourne is, all the way up to the top at the border at New South Wales, where Echuca is. So Melbourne is a coastal region with a temperate oceanic climate and is relatively cold. Due to Melbourne being on the border between the hotter inland areas and the cold Southern Ocean, Melbourne's weather can change very rapidly. This is most common in spring and summer. The further north you move away from Melbourne, the inland areas are typically more arid and hotter. Inland areas generally have warmer climates as they don't have the sea breeze that coastal towns do. Another factor is that water has a much higher heat capacity than that of soil or rock. This heat capacity means that it's hard for water to warm up or cool down, whereas soil and rock, with its lower heat capacity, warms up quicker and dissipates heat quicker. The towns and cities we chose are Bendigo, Ballarat, Shepparton, Maryborough, and Echuca. As you can see, these are all nearly straight north of Melbourne, so they make a big corridor from the bottom of Victoria, where Melbourne is, all the way up to the top at the border at New South Wales, where Echuca is. So Melbourne is a coastal region with a temperate oceanic climate and is relatively cold. Due to Melbourne being on the border between the hotter inland areas and the cold Southern Ocean, Melbourne's weather can change very rapidly. This is most common in spring and summer. The further north you move away from Melbourne, the inland areas are typically more arid and hotter. Inland areas generally have warmer climates as they don't have the sea breeze that coastal towns do. Another factor is that water has a much higher heat capacity than that of soil or rock. This heat capacity means that it's hard for water to warm up or cool down, whereas soil and rock, with its lower heat capacity, warms up quicker and dissipates heat quicker. 10 years of data was gathered for 5 different towns around Victoria from the Bureau of Meteorology. The measure of temperature used was the monthly mean maximum temperature. This means the average of all maximum temperatures during a given month. For most of the graphs in the presentation, January was chosen to be analysed, as it's the hottest month of the year. It was believed that the hottest month would give us better info about regional climates and help us confirm the assumptions about temperature in coastal regions versus arid regions. The first graph we constructed was the monthly mean maximum temperature during January. Interestingly, every month follows this pattern of change over the 10 years. It wasn't initially expected to have such a strong trend, if at all. The inference we made here was that even though each location has their own climate, they still follow these climate and weather patterns. To confirm these patterns, we constructed graphs for every season of the year. We chose the month in the middle of the season to be consistent with January. We yet again see all the locations closely following these patterns and trends, not unlike what we observed in the graph for January. Now, we also see the gap between Ballarat, a fairly cold city, and the others is getting smaller than what it was during summer. In winter, these patterns seem to be a lot weaker, but we can still see some trends. For example, there is a small rise in 2013 and a dip around 2015. During winter, Ballarat is much closer to the temperature of the other towns and cities. During summer, Ballarat was around 4 to 6 degrees cooler, but it's now only around 1 or 2 degrees cooler in winter. The overall range of temperatures is a lot tighter now during winter. A scatter graph that plots temperature against distance from Melbourne was constructed. From this we can see a strong R-squared value and a strong linear relationship. This means the further you are from Melbourne, the higher the temperature. The R-squared value of 0.8552 means that a change in distance from Melbourne accounts for 85.52% of the change in temperature. Note that this is using the data from January, not every month. Although the graphs seem to display a relationship between distance and temperature, something not considered was directionality. 3 of the towns, Bendigo, Shepparton and Echuca, were nearly straight north from Melbourne. Central and northern Victoria are known for being very dry and hot in the summer months. Bendigo in particular is a very dry region. The area was in severe drought between the years 2006 and 2010, which resulted in incredibly strict water restrictions. Maryborough and Ballarat are northwest from Melbourne. Although they are only 58 kilometres apart, they have very different climates. Maryborough is dry and arid. Ballarat resides within the Victorian Central Highlands, which is part of the Great Dividing Range. With the combination of Ballarat's oceanic climate and 435 metres of elevation, Ballarat's temperatures are generally similar, if not colder, than that of Melbourne. If Melbourne's temperature data was added to the scatter plot, it would make the relationship far less strong, as Ballarat is over 100 kilometres away from Melbourne and has comparable temperatures. When we add Melbourne to the graph, we see that Ballarat, which was close to the trend line, is now further away from the line than any other value. Adding Melbourne's data has reduced the R value from 0.925 to 0.824, and the R value from 0.855 to 0.679. While there is still a strong relationship, it's now just less strong. On top of this, the gradient of the trend line has been halved from 0.0631 to 0.0297. When factoring in Melbourne's data, we see that the rate of change in temperature when moving away from Melbourne is much lower than we originally observed. All the locations chosen were north of Melbourne, effectively making it a corridor from central and northern Victoria all the way down to Melbourne. If time had not been a limitation, it would have been interesting to analyse all of Victoria and see if these patterns and changes in the seasons were present in all towns, or just those which I picked. A much more in-depth analysis of factors influencing the weather would give a much better idea of the big picture of why we saw such strong trends in the weather across different towns and cities. It is currently unknown what factors and variables are affecting the weather and climates of these towns and cities. Having a look at weather and wind patterns would shed much more light on the subject. Weather such as big storm and rains generally move from the west to the east, but more research is needed to see how this might affect the data or our overall outcome.